Hi guys, welcome back to yet another class of system modeling and simulation. Today we're going to look at the dump truck problem and see what the hype around this particular problem is and why do the tables in your textbook look so big and complicated. So let's dive right into it. So let's look at this example over here. It says 6 dump trucks are used to haul coal from the entrance of a small mine to the railroad. Each truck is loaded by one of 2 loaders. So you can have 2, 3, 4, how many ever loaders. Similarly, you can have how many ever trucks you want. You want 10, 20, 30, depends on the kind of example you're looking at. After loading, a truck immediately moves to scale to be weighed as soon as possible. Both the loaders and the scale have a first come, first served waiting line for the truck. So these queues over here. The time taken to travel from one loader to scale is considered negligible, that is this point. And then after being weighed, a truck begins a travel time and then afterwards returns to the loader queue over here. So basically, if we simplify this particular example or this particular problem into a much more systematic diagram, this is what we have. So we have 2 loaders. We have a loader queue associated with it. We have a weighing queue and a scale associated with it. So the loader queue waits if the loaders are busy. And once the loader is moved to the weighing queue, one of the trucks from the loader queue occupies these 2 loaders. So we have the weighing queue that is in line to be scaled, and after this particular truck from the scale is done with being weighed, it goes on and travels and continues its journey and afterwards comes back to the loader queue. So hence, this is the model or the simplified model of solving a dump truck problem. So all you need to know is the 2 queues, the n number of loaders that you have, the n number of trucks that are involved in the entire process, and how many scales are there that is being weighed. So the next thing that we want to look at is how do we solve these things. But before that, we need to see how we can break this model down into simpler and smaller components to make our life easier and to also understand how do we go about solving those big tables that you see. The components are first being the system state. So this indicates what kind of state the system is in currently. So there are 4 states that the system can be in. So the first being LQ of T. This indicates the number of trucks in the loader queue that is over here. The next being L of T, that is the number of trucks that are being loaded. This indicates how many number of trucks are there in the loader as of now. So since we have mentioned that there are only 2 loaders, so L of T could either be 0, 1 or 2. If it was 3, it would be 0, 1 or 2 or 3. So that depends on how many number of loaders you have. Then the next thing is WQ of T. That indicates the number of trucks in the weighing queue over here that are waiting to be weighed on the scale. The next we have is W of T, that indicates the number of trucks being weighed. So this indicates how many number of trucks are there at the scale at that moment. So since we only have one scale over here, so it will either be 0 or 1. The next component that we will be looking at is the event notices. So these are the events that occur in the model and should be notified so that appropriate action could be taken. The first being ALQ TDTI. So ALQ is nothing but that indicates arrival at the loader queue. So when a truck finishes the travel time after being scaled and comes back to the loader queue, this is an event and this is represented as ALQ, that means arrived at the loader queue. So ALQ over here. So ALQ arrive at the loader queue, T at what time instance, and DT of I which dump truck has arrived. Then the next event notice is EL, that means ends loading. That means which dump truck has finished ending its loading process. That means over here. So after loading, one of the truck is done with loading. This is another event EL and at what time instance and which truck is responsible for it. Then the next event we have is end wait, that is EW, at what time instance and which truck is responsible for it. So EW would mean after being scaled, after being weighed, the truck is done being weighed and it comes out of the scale. So that is another event and that is indicated as EW. So we looked at system state, event notices, And the next thing is entities. So these entities represent the number of trucks that are there. So since there are 6 dump trucks over here, we represent them as DT1, DT2 till DT6. So this depends on how many trucks that you have and those many numbers to indicate how many trucks are there. The next is the list. So these indicate the queues that are present in the model. So there are 2 queues that we have. The first one being the loader queue over here. So the loader queue has all the trucks that are waiting to be loaded into the loaders, and the next one being the weighing queue that has all the trucks waiting to be weighed on the scale. So these are the 2 lists or queues that are there in the model. Then the next is the activities that are present. So there are 3 activities. One is the loading time, the weighing time, and the traveling time. So the loading time is from the loader to the from the loader queue to the loader, and the weighing time is from the weighing queue to the scale. And the third being the travel time, that is after being scaled, it travels this entire distance and comes back to the loader queue again. So these are my 3 activities, or you can call it time, that is being represented in this model. Then finally we have the delays. So the delays can occur at the loader queue and the delays can occur at the scale. So generally delays are not considered in the system that we are going to be seeing, but it's just good to know that delays can happen, and in the question if they say that these are the delays that are present in the queue, then you need to take into account those time instances also. So now we know the model. We have seen this basic block diagram of how the model works. We've seen the components. Let's go into solving a problem. Okay, so let's look at the problem here. So this problem is taken from the year 2012 or 2011 in the video exam, and it's exactly same as the one that is also given in the Jerry Banks book. It's only tweaked a little bit with respect to the places. Other than that, the table and the numbers and everything is the same. So let's look at the problem. A company uses 6 trucks. So they've given that there are 6 trucks to haul manganese from Kolar to industry. I don't think this should be here. Okay. There are 2 loaders to load each truck. After loading, a truck moves to the weighing scale to be weighed. The queue discipline is FIFO. FIFO is nothing but first in, first out, just like a queue. When it is weighed, a truck travels to the industry and returns to the loader queue. The distribution of loading time, weighing time, and travel time are as follows. Calculate the total busy time of both the loaders, the scale, the average loader time, and the scale utilization. Assume that the 5 trucks are at the loader and 1 is at the scale at time 0. So we know all of this. So they say there are 6 dump trucks. So let's see what's important. So there are 6 trucks. There are 2 loaders. There is 1 weighing scale because they have not mentioned how many weighing scales are there. And they say so there's 1 weighing scale. Then they say the queue, that is FIFO. So that is as per norm. Then when it is weighed, a truck travels to the industry and returns to the loader queue. So there is some travel time involved. And they've given the distribution of the loading time, weighing time, and the traveling time. What they want us to find is the busy time of both the loaders, the scale, like how much time was the loaders busy, how much time was the scale busy, the average loader busy time, the scale utilization. So we'll come to that. How do we go about arriving at these answers? But the important part in this question is actually the last line. So it says, assume that the trucks are at the loader and 1 is at the scale at time 0. So this is crucial as to it will help us to start solving the sum and to get an idea as to what the scenario is at time 0, so that we can move ahead and calculate the rest of the things like busy time of both the loader, scale, average loader, and scale utilization. So as usual, let's look at the solution. So I'm pretty sure every one of you would have seen this enormous table in the textbook or in the solutions of the sums, but it's very simple. It's just they have discretized it a lot and specified every detail, and we're going to go through each step and see how this was arrived at, how this was arrived at, how we get this, and finally this. So don't get scared, don't get demotivated, and let's look at our model right now. So we saw this a few minutes back, right? So this is our model. Now let's make it the way we want it, because we need a queue and we have two loaders. Let's make it to our convenience so that we can start solving sums easily. So we have this loader queue. So it has a number of places where the trucks can stand. We have two loaders as mentioned in the question, and we have a weighing queue where the trucks can weigh, and we have one scale where the trucks are weighed, and then we have this path that the trucks take to arrive at the loader queue again. So the time over here is negligible, the time over here is negligible, the time over here is negligible, but this time is accounted for. Now let's look at all the terms that we have to evaluate, calculate at each step. So one is the clock instance t, that means at 0 to whatever time it takes, at that time instance, LQ of t. So this is nothing but what we saw, the state. How many trucks are there in the loader queue? How many trucks are there in the loader? How many trucks are there in the weighing queue? How many trucks are being weighed? What are the truck numbers in the loader queue? The truck numbers in the weighing queue? The future event list? And then finally, BL and BS. BL is load busy time. BS is scale busy time. So we have seen all of this a few minutes back. The only new thing is these three things at the last. So we have this table of the distribution of the time, and now they have also given this very important line in the end of the question that says assume 5 trucks are at the loader and 1 is at the scale at time 0. So we know that the first entry in that enormous table of ours is going to be this. So clock 0. How many loader queue will come to this? But for certain we know is that 1 is at the scale. So let's say 1 in the that is being weighed. Since none of them are in the weighing queue, because they say assume 5 trucks are at the loader and 1 is at the scale. Totally there are 6 dump trucks, out of which 5 are in the loader, 1 is at the weighing scale, and since all of them are here, 0 of them at the weighing queue. Now how do we distribute this? Since there are 2 loaders, 2 of them get filled in the loaders, and how many are remaining? 5 minus 2, 3. So 3 of them are waiting in the loader queue. So we have the first instance at time 0 as to what the scenario is and how the trucks are distributed at time 0. Now since it's the first time instance, nothing has happened, clock is just 0, the loader and the BL is BL and the BS is going to be 0 because nothing happened, it's just about to start. So BL, like I said, indicates how much time the loaders are occupied, and BS represents how much time the scale is busy. It's basically saying if this was in seconds or minutes or whatever you take, I think minutes would be appropriate. How many minutes the loader was busy, how many minutes the scale was busy at this particular time instance. So BL and BS is going to be cumulative, because after this, when it's say clock 10, you have to account all the cumulative time that has occurred till time instance 10. So this is our first instance, and now let's populate the table. So we have filled this thing. We said that there are 3 in the loader queue, 2 in the loader, 0 in the weighing queue, 1 in the weighing scale. So let's first fill this part. So let's say truck 1 is here. So I'm just going to write truck 1. Then nothing in the weighing queue, 2 in the loader. So I'm going to write T2 and T3. Then there are 3 waiting in the loader queue. So I'm just going to assign T4, T5 and T6. Right? Now coming to the most important part. So this is basically your structure. This is basically your entire flow, and this is going to be very critical because you're going to be filling each of these boxes and filling the next column, that is the future event list. So we saw that there's something called future event list. Future event list indicates what are the events that are going to happen in the future with respect to the present scenario that we have. So assume some time t passes. What are the events that are going to happen? So one event that is going to happen is T1 is going to finish weighing. After some time, it is going to finish weighing, right? So that is going to be my end weighing. One of the event notices. So end weighing at time t, what is it going to be? We'll come to that. But before that, let's write down which dump truck is going to do that. That is T1. Now, how do we fill this number? So, how do we fill this number? The answer is the clock time plus the time got from the distribution. So, at this instance, clock is 0. And since this is the first weighing time, so we need to look at our table. That is this, the weighing table. So, this is also gone. So, we have to consider 12. So, it's going to be 0 plus 12. So, that's going to give me 12. So, that is one future event list, where T1 is going to finish weighing at time instance 12. Then the next is going to be this truck. So, this truck is going to finish end loading. Because it's in the loader, it's going to finish loading at time instance. How are we going to calculate that? It's the same as this formula. So you have clock of t plus the distribution of the loading, correct? So we have the distribution of the loading. So this is going to be 0 plus, now let's look at our distribution table for loading. That is going to be 10. So if we move down, that's going to give me 0 plus 10, and that is 10. Okay, now another truck that is going to finish is truck 3. T3, it's going to be the same thing as truck T2. It's going to finish end loading. So the truck is going to be 3. And how are we going to calculate the time? It's going to be 0 because time instance is 0. 0 plus another loading time distribution. So we're going to look at the distribution time of loading. And we get that from the table. So 10 is already done. Now 5 is there. So we take 5. So that's going to give me 0 plus 5. That is equal to 5. So these 3 events that you see, these are my future events list. So now out of these 3 events, we're going to choose the eminent event. And how do we choose the eminent event? Eminent event is the event which has the least time, right? So among 5, 10 and 12, which is the event that you're going to choose? You're going to choose 5 because it's the time, it's the event with the least amount of t. So we say this is our eminent event, and then we move one step further and we come to clock instance 5. So this is where our next step is going to be, or the first column, how we are going to fill. So in the next instance, we arrive at this place. Now the clock is going to be 5. Okay, 5 because the eminent event chosen in the previous thing was 5, and hence we advance till 5. Now, how is it going to look like? Now, since we chose this event, so let's write down the event that we had chosen. We had chosen the event of what? End load 5, and which was the truck that we said we're going to take? T3. So, this was our eminent event. So, now this means that end loading of T3. So, if it ends loading, where is it going to move? It's going to move in the weighing queue. So, from here, it's going to move to the weighing queue. So let's write this as T3. Now, what was already there in the scale? There was already T1. So I'm going to let that be as it is. So if you can see for your convenience. So T1 was here. T1 was here. This has just gone here. T3 has gone here. T2 is going to be where it is. But since one loader is empty, one of this is going to come and take place. So that's what we're going to do. It's just following the most logical thing that is to happen. So T1 is here as usual. T3 comes to the weighing queue. T2 is already there. But from the loaded queue, one of the truck comes and takes its place. So that's T4. So how many are left in the loaded queue? 2. So T5 and T6. So that's what we get from this. So T4 comes here, T3 goes here, T5 and T6 advance one step. Now You can fill this table. So how many there in the loader queue? 2. How many there in the loader? 2. How many there in the weighing queue? 1. How many there in the weighing? 1. We'll calculate this in a minute. But first, let's write the future event list. So how do we write the future event list? So this is going to be the same as the previous one because it's just time at 5. So this is going to be end weighing 12 and T1. This is something new because this is a new entry. So what is this going to be? This is not going to be there, right? So we're not going to consider T3 because the time taken from here to here is considered negligible. Hence, this event is not taken into account. So the events that are taken into account is end weighing, that is over here, end loading, and arrival at the loader queue. So T2 is already accounted for in the previous step. So that's, I'm just going to copy it. So that's going to be end loading 10 of T2. And then this is new, right? This is new. So this is going to be, it's again going to be end loading because it's in the loader, which is the truck T4. And how do we calculate this? This is going to be the clock, but here the clock is not 0. Our clock over here is 5. So it's going to be 5 plus. Now, how do we calculate the loading time? Over here, this is gone, and this is gone, right? Yes. So this is gone and this is gone from the previous step because there were 2 events that we took into account, and hence this graph. I'm just rewriting the graph so that I don't have to move up and back and forth every time. So now this is gone. So the next loading time that is we're going to consider is 5. So that will give me 5 plus 5 is equal to 10, and that is going to be replaced here. So now we have 3 events. So basically we have this, we have this, and we have this. Now, the thing that we left out was BL and BS. So BL is how much time is spent in the loader and BS is how much time is spent in the scale. So from time 0 to 5, were there any, was the scale busy and were the loaders busy? Yes. How many scales? Since there's only one scale, so we can say in that time lapse that happened between 0 and 5, there was one truck in the scale. So we can say for 5 minutes, the scale was busy. So we can get BS is equal to 5. Then how do we get BL? So BL is going to be how many loaders were there? Since there are 2 loaders, this one and this one, and both the loaders were occupied, so that's going to be this 5 plus this 5 because it's simultaneously happening. Both the loaders are doing the work simultaneously, and the time lapsed is 5 minus 0, right? So the time lapsed is 5 minus 0, that is 5, and since there are 2 loaders, it's going to be 10. So how the 10 minutes the loaders were busy, and for 5 minutes the scale was busy. So you have these things. Now comes choosing the eminent event. So how are you going to choose the eminent event? The eminent event is the one with the least time. Now since there are 2 events with the same time and those are the least, we choose any one of them. But since this has happened first, or let's take it alphabetically, we choose this one. So let's say we choose this one. So in the next step, what is our clock cycle going to be? Our clock is going to be 10.